Okay, good morning once again.
Good morning, sir.
I hope you guys are all doing well, right?
Yes,
Okay, we thank God. We thank God. We thank God for giving us a new life with strength on this day. Okay. Okay. Um, so today our objective is to be able to state your null hypothesis and also to be able to draw your conclusion make your decisions with regards to probability values or p-values. So that is our objective for the day. Your ability to state the null and the alternative hypothesis and the ability to make a decision. That's to accept or reject the null hypothesis based on the p-value and the signal cancelling. Okay, and then God willing, next week we will start with the dependent t-test and then we move on. Okay. I hope that's clear. Okay. So I think I can start. Can we start the class?
yes, sir.
Okay. Okay. So today what we are going to do is hypothesis testing. So today we are going to talk about the null hypothesis and then the alternative hypothesis. So from previous studies, we learned that based on the population, we are able to generalize for the we are able to draw sample. And based on the sample, we are able to generalize for the whole population. And this sample, we can get it based on the sampling techniques. Okay, so we can use the sampling techniques to get our sample. And then from there, we can now generalize for the whole population. Okay, so basically that's what we are going to do today. I've talked about these things, descriptive statistics, inferential. So let me start from the hypothesis. So hypothesis is just a statement about the population. When we say hypothesis, it's just a statement about the population, and this statement can be true or false. You are just making a claim. You are making a statement or a claim about the population, and this thing can be true or false. It can be true or false. So someone can make a claim about your class that, let's say, 90% of the class are interested in biostatistics. So he's making a claim. And this claim can be true or it can be false. This claim can be true, and at the same time, it can be false. So you need to do what? That's where you need to apply your hypothesis testing. So based on your hypothesis testing, you will be able to now come and tell us that, oh, whatever this guy said or whatever this person said about this is true or it is not false. And that's where we make good use of this hypothesis testing, where we accept or reject the null hypothesis. Okay. So another person too can make a claim about, let's say he's coming up with a product, and this product, let's say he's saying that this product is about, let's say, vitamin. So he think that if you take in these vitamins, yeah, the weight of your baby may increase or probably, yeah, may increase if you take these vitamin pills. So he's making that claim. So what you need to do is you need to go and assess. if that claim that this person is making is true or false. Okay, so you need to go and check if whatever the person is saying is true or false. If whatever the person is saying is true or false. So you need to go and check. You need to go and check if that claim is true or false. So what you can do is making good use of hypothesis testing. Hypothesis testing. So you can now test your hypothesis based on the information that you have in there. You can now go and test your hypothesis. Okay, you can now go and test your hypothesis. So that is what we are going to do today. So a hypothesis is just a statement about the population. Okay, you just make a claim about the population. And this claim can be true or false. And on the slides, you can see that someone is making a claim that 75% of women receive antenatal care. So it's a claim. You need to go and check if truly that 75% are receiving antenatal care or not. Okay. And then another person is saying that antenatal care is high among educated women. So it's a claim. And this claim can be true or false. Is it true that all antenatal care uh, rates is high among educated women? Is it true? Yeah, you need to go and check if truly is that or not. So you need to state your hypothesis. Okay, and this hypothesis, you have what we call the dependent hypothesis. Sorry, we have what we call the research hypothesis and the statistical hypothesis. The research hypothesis and the statistical hypothesis. Please give me some few minutes. I need to give me some few minutes. Let's continue. So we have what we call the research hypothesis and the statistical hypothesis. So when you say research hypothesis, the research hypothesis is what motivates you, the researcher, to go and conduct that research. So whatever that motivates you to go in and do that research, it's what we term as the research hypothesis. Okay, so for example, the example that I cited that someone is saying that 75% of women receive antenatal care. So you see that probably you are in that facility, and then you are making, based on your observation, you are looking at probably all those who are coming, about 75 of them are receiving antenatal care. So that is motivating you to go and check if truly 75% of women in there are receiving antenatal care. And so somehow this is called research hypothesis. Okay, so whatever that motivates you, whatever that may ginger you, or any guess that you make about the population is what we term as the research hypothesis. And the research hypothesis will lead you to what we call the statistical hypothesis. Okay, so once you know your research hypothesis, then that one will lead you to your statistical hypothesis. And this statistical hypothesis, you have to state it such a way that you get the null hypothesis and the alternative hypothesis. The null hypothesis is stated in such a way that it reflects that there's no association in whatever you are doing, or there's no difference, or there's no impact in whatever you are doing. And then the alternative is always the opposite of the null. And so the null is telling that there is no association, there's no difference, there's no impact. Okay. And then the alternative is now telling us that there is an association, there is an impact, there is an improvement, there is an effect, there is a change. Okay. So the alternative is always telling us that there is a change, and that is the researcher's objective. Alternative hypothesis is a researcher's objective. Okay. And normally we denote the null hypothesis as H subscript 0. H subscript 0. So the moment you see or H subscript 0, then it means that that is the null hypothesis. And the moment you see H subscript 1 or A, or let's say I, H subscript 1 or A is what we refer to as the alternative hypothesis. And it is the alternative hypothesis that the researcher seeks to find, or the researcher's objective. Okay, so the alternative hypothesis is always a denoted as H subscript A, H subscript A, H subscript A. And then the null is also denoted as H subscript 0. But please keep in mind that the null is always denoting or telling us that there's no effect in whatever we are doing. And so if we are to refer to the previous example, that someone made a claim that 75% of women receive antenatal care. So based on this 75% of women receiving antenatal care, now this can lead us to form our statistical hypothesis. And this statistical hypothesis from this statement that 75% of women receive antenatal care, we can state it like this. So I'm going to state the null hypothesis for you. Oh, one person can say that the
Sir,
percentage of women, yes,
sir, please, they said
yes,
your voice is low.
my voice, every day my voice is low. What do I do? What do you want me to do? Hey, always my, please. Okay, you yourself, is my voice low? You yourself,
Sir, for
you,
me, there is okay, but
it's okay.
different. So,
They have to check. They have to increase their volume. Probably it's coming from their side, please. Okay, please. Sisters, please check. Probably it's coming from your side. Okay, please check. You can increase the volume of your earpiece or your laptop or whatever you are using, please. Okay. So let's continue again. So what I was saying was the statement that 75% of women receive antenatal care. You can write your null hypothesis like this. Um, 75% of women are receiving antenatal care. That is the research hypothesis. So now I'm going to state the null hypothesis for you. And that doesn't necessarily mean that you should all use it that way. Okay. So someone can say that the percentage of women receiving antenatal care does not change or remain the same as 75%. The percentage of women receiving antenatal care remain the same as 75%. Okay. And then the alternative hypothesis is now going to tell us that the percentage of women receiving antenatal care changes, or there's a change in the percentage of women receiving antenatal care. And you can see that this statement is reflecting that the now there's no difference. So if there's no difference, it means that no matter what you are doing, it's the same as 75%. No matter the education you are giving, no matter the subsidies, whatever, it still remain the same as 75. There's no change. And that's what the now is telling us. And then the alternative is telling us that there is a change. And now when there's a change, then we are saying that the percentage of women receiving antenatal care is not is not the same as 75, or it's not equal to 75. It is not equal to 75. So if it is not equal to 75, then it means that there's a change. Another person too can choose to state the null as the percentage of women receiving antenatal care is equal to 75% for the null. So if it is equal to 75% for the null, then that means that it remains the same. There is no change in whatever you are doing. And that is how you state your null and alternative hypothesis. Okay. Okay. So I want someone to try this. Or if you have any questions so far, you can raise your hand. Okay, so my dear, let's take questions concerning the explanation that I've given so far.
okay, sir. Sisters, please, any questions?
Okay, so we are not getting any questions, so let's continue. So
Sir, someone's hand is raised. Victory.
okay, call the person.
Victory Sado. You can ask your question.
There.
Yes.
Okay. Please, the example that you gave, the 75% women receiving antenatal care. Sir, please, can you go over? Because I was confused, like when you were explaining it with the null hypothesis and the alternative. Thank you.
Yeah, I was saying that the now always reflect that there's no impact in whatever you are doing. And so if that's the case, someone is saying that 75% of women receive antenatal care. So if whatever you are doing does not cause any impact, what are you going to say to reflect that what you are doing does not cause impact? So it means that it's the same. So you have to state in such a way that it reflects that there's no change in whatever you are doing. And so I stated the null hypothesis as the percentage of women receiving antenatal care remained the same as 75% as the null. And then the alternative, I stated that the percentage of women receiving antenatal care is not, I mean, greater than or it is equal to or more than that. Okay, because if it is more than that, then there's a change. So if the now is telling you that there's no change, that means that the percentage remains the same as 75%, then the alternative will tell you that it does not. I mean, there's a change. So when there's a change, then it means that it is not the same as the previous one. Okay, so that is the concept. Just keep in mind that the now will always and always tell that there's no difference, there's no change. So if the 75%, let's assume that, let me put it this way, the now, the now will always tell you that it is the default. Let me use that word, default. So for example, this 75% that someone is claiming that uh, there's no change, or let's say 75% are using the antenatal care. So by default, that is the claim that that person is making, that 75% are using antenatal care. And so whatever that you are doing, probably you came up with some policies here and there. So now you want to go back and check if truly the 75% of women are using antenatal care. And so by default, it remains the same. That means that whatever policy, whatever thing that you did is not having any impact. So if it's not having any impact, then the default remains the same. So by default, 75% are using antenatal care. And so then it implies that the now it should reflect that. And so if you are stating it, you can state it that 75% of women are what? Using antenatal care. Or the percentage of women using antenatal care is equal to 75. Or there is no change in the percentage of women receiving antenatal care. You can see that all these three statements are reflecting that it remains the same. Or someone too can say that there's no difference. There's no difference in the percentage of women using antenatal care, even after probably you did your policy or whatever. There's no difference. So if there's no difference, that it means that it remains the same. Now, as I said, the alternative is just the opposite of the now. So if the now is telling that the percentage of women receiving antenatal care remain the same, okay, remain the same, then the alternative should be the opposite. So now the percentage of women receiving antenatal care change, or there is a change. There is a change in the percentage of women receiving antenatal care. Okay, or if probably the direction that you are looking at, probably per your policy, you think that it should increase, then whatever you are saying should reflect the increment based on your policy. But if the policy is reduction, then well, whatever you are saying should reflect it. So let's start with let's say, assuming per your policy, you think that the percentage of women should increase. And so the alternative should reflect that thing. Okay, so now that one too, someone can say that if only the objective was to check that the percentage of women receiving antenatal care should increase, then you can state your alternative like this. The percentage of women receiving antenatal care has increased because that is the objective. And if you remember, I made mention that the alternative hypothesis is always the researcher's objective. So it depends on the uh, whatever that you want to find or the research hypothesis. I hope I've made myself clear. So now let's call the next person.
Teresa Tiwa.
Oh,
Teresa, you can mute yourself and talk.
Simon. Okay, she's not talking, so I think we can move on.
Hello, sir.
Yes.
So meaning the alternative hypothesis, it can be more or less.
No, yeah, it can
It's
be
not
more.
always okay.
Yeah. It depends on the scenario. I think I have one example. So it depends on the scenario. Probably
Okay.
let me use this. Probably there's a drug, and you think that this drug will improve, let's say, the improve the weight. Let's say the weight of there's a vitamin that you think that if pregnant women taking this vitamin, it should increase the weight of babies. So you see that this time around here, you are thinking that the vitamin or the what is motivating you to go and then check that if you take in the vitamins, it should increase the weight of the baby. And that's what is motivating you. And so this one, if you are stating your null hypothesis, then now we'll always tell that the weight of the baby remains the same. That's even if you don't take the vitamins, the weight should be the same. So now we're going to tell you that there's no change in the weight of the baby even after taking the vitamin pills. That is the now. And then this time round, the alternative here, it should reflect the impact that you are looking for. You see, at this time round, the impact that you are looking for is what? Increase in the weight. So you don't just come and tell me that the vitamin pills is causing an impact on the weight of the baby. Fine, it is causing an impact, but this time, which impact are we looking at? Is it decreasing it or increasing it? Here, your objective was what? Increasing. So the alternative should reflect it. And so now, finally, your alternative hypothesis can be stated as the vitamin pills increase the weight of the babies after taking it. I hope this is clear. I hope I've answered you, right? Okay, so I think she's fine. She's not talking. Let's move on. Can we move on?
Yes, sir.
Okay. Okay. Okay, so I wanted you to try this one. Please try this for me. This, I'm going to highlight it. I want you to look at it and see if you can come up with your null and alternative hypothesis. Please look at it. Please look at it and see if you can. Please look at it. If you can try the null and alternative, you raise up your hand and we call it. Okay. Ajubi, Augustina, try it. Ajubi. You can unmute yourself, Ajubi. Ajubi, you can unmute yourself. Oh. Okay, so Ajubi is not talking. Let me call Ophelia Atta. Ophelia, talk.
Okay, so I would say that the use of contraceptive use in rural areas will remain the same as at 70% will remain the
Oh, no, no, no.
same. So
Look
that
at
will
this
be
one.
the
There's no 70% in there. Look at the statement
okay.
here.
So
Look at this, the
okay,
statement
so
here. That's what we are doing. We are done with the first one. So look at it and then come back again, okay? Elna.
okay.
Okay,
Emanuela.
good. Thank you. Good.
Hello.
Yes.
Okay, I would say there is no change in improvement in contraceptive use in rural areas, regardless of the outreach of health workers.
Okay. Okay. So that is it the null or the alternative? Manuela, what you said, is it the null or the alternative? Okay. Ophelia Atta, you to talk.
Okay, so say the use of contraceptives in rural areas will not improve regardless of the health workers going for outreach programs. So that will be for the null hypothesis.
Okay.
And then with the alternative hypothesis, the use of contraceptive in rural areas will be improved due to outreach programs by health workers.
Okay. Okay. That's fine. Okay, let's listen to Abigail.
Abigail, you can unmute yourself now. I'll send you a message.
Okay. With the null hypothesis,
Oh, Abigail, you can talk.
hello, sir. With the null hypothesis, I will say that the health workers' outreach have no significant effect on contraceptive use in rural areas. And with the alternate hypothesis, I will say health workers' outreach significantly improved contraceptive use in rural areas.
Okay, but the first one, is you just use significant, but this significant, what does that mean? Is it improvement or what? Okay, that's okay.
Okay, sir.
Then let's take the last one. Then we go. We can continue. Now the last one.
Emanuela. Emanuela, you can
Okay,
unmute
okay.
yourself.
Okay. With the alternative, I can say the outreach by the health workers caused a tremendous improvement in the use of contraceptive in rural areas.
Okay. That's fine. Okay. So all what you said is right. All what you said, but you can see that here everybody is dwelling on this word improving. So that's the most important thing in the sentence. And then you can see that it's all about contraceptives and then the health workers. These two guys. You can see that every statement involve the health workers, contraceptives, and their interaction was the improvement. Okay, so that's okay. But in fact, these are the things that you do in the exam. The inferential statistics. These are the ones that you are going to write in the exam. So that's just by the way. Okay. So
Our end of exam, sir.
that one that I don't know. I said your exam. So it's part of it for end of semester. Even tomorrow, if you write exam, it's part of your exam. Even if you write exam next week, it's part of your exam. So every exam is exam. I hope I've answered you.
Yes, sir.
Okay. Okay. I think we can continue. Emanuela, do you have a question or what? Your hand is still up. Okay, so please, let's continue. Sorry, my sisters, I'm having some catarrh, so that's why. Okay, so let's continue. So this is how I stated it. The visits by the health workers do not increase contraceptive prevalence rate. So you see that do not increase. So if it doesn't increase, then that means that there's no improvement. Okay. And the alternative is saying that the visits by the health workers increase contraceptive prevalence rate. So if there's an improvement, then there should be an increment in the contraceptive usage. Okay. And that's what I mean by improvement. So it doesn't necessarily mean that always you go by one direction. I mean, one sentence. It will vary. Okay. But they should be telling us the same idea about no effect and effect. Because then now will tell you that there's no effect. And then the alternative is telling us that there is an effect. Basically, these are the things that the statistical hypothesis portray. Okay. Now, whenever you are dealing with quantitative variables, you can write your null hypothesis in mathematical notations, which I will not bother you so much with these mathematical notations. But I've placed it part of your lecture notes so that you know that you can do that. But for you guys, I don't have any problem. I will even want you to state it in sentence form as you just practice. But you can still use the mathematical notation by making good use of the equal sign, less than or equal to, greater than or equal to symbols, and then you are good to go. But I place there just for your vision so that you know that this thing is available. And so if you are writing something, let's say if you are reading and you meet it, it will not be a problem. Okay? Don't be a problem. Okay. And again, this also is part for you to know that you can also test for proportions. Let's say you want to check for proportion, percentage of two population, you can compare proportions. So I've also put in this there for you to know that you can also check for proportions. But for this course, we are not going to test proportion. We are not going to test proportion. What we are doing is test of means. That's what we are doing. But this thing is there so that in the near future, if you come by these proportions, you don't think that it's not possible. Okay, so this is possible. So please give me some few minutes. I will come and talk about the level of significance. Okay. Okay. So another important thing in hypothesis testing is this guy that we call the significance level. The significance level or the alpha. The significance level or alpha. The significance level or alpha. So for the significance level, for the significance level, you need to set it yourself. Or the alpha level, you need to choose it yourself. In most cases, we set it at 0.05. Most cases, we set it at 0.05. So you will have to choose your own alpha level. And for health-related research, most cases, you have to use 0.05 or 0.01. That's a 5% significance level or 1% significance level. And so the significance level is a benchmark that we use to accept or reject the null hypothesis. And so based on the significance level, you are going to accept or reject the null hypothesis. Okay, based on the significance level, you are going to use it to accept or reject the null hypothesis. I hope that's clear. So whatever you get, you are going to compare it with the p-value. There's something we call p-value, probability value. And this probability value is always associated with the test statistic. The probability value is associated with the test statistic. And so if you have your significance level, then you compare it to the probability value. And this significance level is also referred to as the type 1 error. The type 1 error. So the error that is associated with rejecting the true null. So whenever you set your alpha level, it is telling you that the error that is associated with rejecting a true null, which probably in fact it is true. So the significance level, that is the reason why we always want the significance level to be very small, so that it should be something negligible. Even if we make type 1 error, that means if we reject a true null, okay, even if we reject a true null, it's something negligible. So you always have to, set your alpha level. And before I continue, I want to ask a question. Let's assume this is the pregnancy test kit. If I do my pregnancy test and I have this, is it positive or negative? Class rep, answer me. I want only the class rep to answer. Gloria, or is it Gifty? Is it Gifty talking now or Gloria?
Sir, it's negative.
Okay. Okay. Negative. Negative. Okay. So this is the control line. Is that not it? Is that not it? So if you see the control line, then it means that it's not negative. Right?
I can't see the line.
Oh, this line, the first line, this line. Can you see it now?
Yes.
So that line serves as what? Control. The control. Is that not it? Oh. Okay. So that is the control line. So you are using the control line as the benchmark. Is that not it? So now the control line serves as a benchmark. The moment you get another line, then it becomes positive. So you compare this with the control, and then you are able to tell us that there is some evidence that the person is pregnant. You are able to conclude that there is enough evidence that the person is what? Pregnant. Okay. So the same thing is what we are doing here. Okay. So we always choose a benchmark, alpha, and then we compare it to the p-value. And based on that, we are able to draw our conclusions. We are able to either accept or reject the null hypothesis. Again, based on the significance level or alpha, we are able to do what? Accept or reject the null hypothesis. And don't forget that I said that this is the benchmark. And the p-value, as I said earlier, the p-value is always associated with the test statistic. It is always associated with the test statistic. It doesn't just come, go and then you pick it. You don't just go and pick it. Okay? You must get it from somewhere. And how do you get it? It is associated with the test statistic. Okay? So I will show you how to get the p-value from the table. But in fact, for exam's sake, I normally quote the p-value for my students. I quote the p-value for the students. And based on that, they are able to tell me either they are rejecting or accepting the null hypothesis. Okay. And then they can now draw their conclusion. Okay. So now, this is the rule. Please listen and listen very well. Listen and listen very well. I don't want anybody to come and then ask me again. Please, I'm pleading with you, listen and listen very, very well. Okay. So when I write PV, it means p-value. Okay. It means p-value. And so whenever, this is the rule, listen to me, that's the rule. When I finish, you ask your question, please. Whenever the probability value is greater than the significance level alpha, then it is in favor of H naught. That's the null hypothesis. That means that we are going to accept the null hypothesis. Okay? Whenever you have your probability value greater than the significance level, we are going to do what? Accept H naught, the null hypothesis. And then the other one, whenever your PV, when your PV is less than the significance level, that one is in favor of the H1. And H1 is what? The alternative hypothesis. And that is where we say that you are what? Rejecting the null hypothesis. You are rejecting the null hypothesis. Okay? Because probability value is less than the significance level. It means that you are rejecting the null hypothesis. Okay? You are rejecting the null hypothesis. And in statistics, whenever you reject the null hypothesis, that is what we refer to as statistically significant. Statistically significant. Okay? And that is the rule. It is the general rule. You go by it. I don't want to go into it. It is the general rule, and it is accepted, and it is because of this guy that we are rejecting the null hypothesis. That is the general rule. That is the general rule. Okay.
So please, someone said come again.
I'm saying that the probability value, whenever is greater than alpha, it is equal to H naught. That means that it is in favor of the null hypothesis. Whenever your probability value is greater than alpha, it is in favor of the alternative hypothesis. Sorry, the null hypothesis. Please give me some few minutes. I need to check on my children. I'll get back to you, please. Okay, so sorry about that. So what I'm saying is, this is the rule. The rule is, whenever your probability value is greater than the alpha, it is in favor of the null hypothesis. Whenever your probability value is greater than the alpha, it is in favor of the null hypothesis. And then on the other hand, when your probability value is less than alpha, it is in favor of the alternative hypothesis. Whenever your probability value is less than the alpha, it is in favor of the alternative hypothesis. That is the rule. That is the rule. And that's how we accept or reject the null hypothesis. Okay? Okay, so please let's take the questions before.
Okay. Ajubi, you can mute yourself.
Mute yourself.
Hello, sir.
Yes.
Please, based on your explanation, I understand. But when I read the sentence there, I don't get it.
Which sentence are you reading?
The level of significance under I don't understand. I can't relate it to your explanation.
Please, I can't hear you. You better talk louder. I can't hear you.
Please, based on your explanation, I do understand, but when I read it, I can't relate it with the explanation.
So
It's
which
making
one?
me
I'm
like,
asking which one are you reading?
since to reject a true null hypothesis with constitute an error, that one I don't understand.
And I'm saying that what I'm saying, did I mention any error here? I explained the level of significance, what it is. And now I told you that the level of significance, that is what we use to reject or accept the null hypothesis. Okay? And I mentioned that the level of significance is the same as the alpha, and that one is termed as type 1 error, the probability that you are going to reject a true null. That is what the significance level is. And now what I'm saying is, this is how you accept or reject the null hypothesis. You always have to compare your probability value with the significance level. Okay? So you have to compare it with the significance level. Then you can now accept or reject it. So that is different from whatever you are reading here. Oh, please.
Okay, sir. Thank you.
Okay. Please, if you have another hand, we can call the person.
Josephine, you can talk. Oh. Teresa,
Hello,
Chua, you
sir.
can talk now.
Sir,
Yeah.
please, the point where the alpha value is greater than the probability value, you said it is in the favor with the alternative hypothesis. And sir, please, you gave a name to it. Please, I didn't get that part. So
What
you said
name? You said,
significant something.
oh, that's what we say is statistically significant. All these things that I'm
Okay.
saying is in our subsequent slides. All these things that I'm saying, you will find them in our subsequent slides. But I want to relate the significance level with the p-value so that you get a concept. Okay. So you don't worry. I think in our subsequent slides, they are there. So whenever you reject the null hypothesis,
Okay.
and that is statistically significant. Whenever you reject a null hypothesis, it is statistically significant. Okay, Josephine?
Hello, sir.
Okay.
Sir, please,
Yes.
I'm a bit confused. Sir, please, with what you are teaching, are we going to be given some figures, then we will be calculating for the level of significance and others that you are talking about?
No. Please listen to me and get the concept. I'm saying that you, the researcher, you will need to choose your significance level. And this significance level, most cases, we set it at 0.05. Okay. And then the next thing is to accept or reject the null hypothesis. And you can only accept or reject the null hypothesis based on what we call the probability value. Okay, and these probability values, as I said, they are associated with the test statistic. Okay, the test statistic. And this test statistic, you will need to compute it. You do some calculations, and then you get your test statistic. That's the manual thing. That's the manual thing. And then you get your test statistic, and then you can go and then read your probability from a table. So based on the table, you can now tell us that, oh, now this is the probability value. And you can now come and compare it with the significance level to draw your conclusion. Okay. But I mentioned that for exam's sake, since you guys are just applying the statistics, and to be frank with you guys, in real life, this manual thing, I don't think you will use the manual, do this thing manually. In real life, you use softwares to do these things. And so that's the reason why I want you to be able to interpret p-value, because wherever you find yourself, probably if you are doing your master's, PhD, wherever you find yourself, any research, you will get your probability value. And based on the probability value, you are able to accept or reject it. And so for exam's sake, I give out the probability value. My students will compute the test statistic. Normally, that's what I do. Okay?
Okay. Thank you.
Okay.
Where's Jesse?
Okay, sir. Please, I want to find out at which point do you reject the null hypothesis? Is it when the probability value is less than the null hypothesis, or when it's greater than?
No, you don't deal with null. You compare it with alpha. And so whenever the probability value is greater than the alpha here, you can see I wrote equal to the H0, that's the null hypothesis. And whenever the p-value, the probability value is less than the alpha, that one too, you are going for the alternative. And that means that you've rejected it. Okay? So you accept when it's greater, you reject when it's less than. Okay, so let me just chip in this. Before, okay, actually, let me take the question. The next question.
Owusu Jennifer. Jennifer Owusu. And I need Jennifer.
Yes, please. So I wanted to ask, is the alpha, or let me say the significance level, is it in relation to what we did as in in relation to the sentence you gave earlier that we did the now and the alternative? Like, I'm lost. Is it in relation to that? Or is a different thing altogether? I'm lost.
But that one, did I mention it as significance level or a margin of error?
That is the problem, sir.
No, I'm asking you. You didn't answer me. I said that, did I mention it as a significance level or the margin of error?
Margin of error.
So why do you want to force yourself and say that it's the same? Or is it because the figures are the same, 0.5, 0.05?
So the whole thing is I'm lost. I'm lost
No,
with the
don't justify that you are lost. Make things simple
the
for yourself.
level of significance. Let me put
You are
it
making
this way.
things difficult for yourself, my dear.
Yes, so I am
You are
lost.
making it difficult for yourself. It's not a matter of you are lost. This is margin of error. This is significance level. But
Okay.
you want to force yourself that they are the same.
So the
How can
significance
no,
error
no, no, no,
is the difference between the two.
wait, I'm coming. How can a midwife in Kumasi be the same midwife in Accra? All because they are midwife, you think they are the same? I'm asking you because there's a midwife in Kumasi and there's a midwife in Accra. Is it because they are all midwives? They are the same. Is it possible? I'm asking you.
Yes, we are. Yes, we
So
are.
yes, they are the same. Are you not doing the same anatomy?
Sir,
So they're the same human beings.
some did protocol. That's why they were posted there. So we are the same.
No, you are not getting my point.
Okay.
Listen to me. Listen to me.
In terms of
If
human,
listen to me, please listen to me. Listen to me. I have Gifty in Kumasi. She's a midwife. And
okay.
I have the other person. Let me see. The other person is okay, you yourself, Jennifer.
Uh-huh.
You are in Accra. You are in Accra, right?
Okay.
Okay.
I'm in
Are you
Sunyani.
guys the same person? Are they the same person or the same individuals? The fact
Okay,
that
we
you
are
are all
not the
midwives.
same.
So why do you want to force yourself that they are the same? Okay, let me make it simple. They are not the same. I've
Okay.
answered you.
Hey.
Titi.
Then, sir, please, can you just go over the level of significance again, where the alpha and the p-value all came? I'm lost.
I should do what? I should do what?
Go over the significance level.
What actually do you want me to say about it? What's bothering you on
I
that?
don't get it. I didn't get the whole thing. I'm lost.
I said that it is serving as a benchmark for you to accept or reject the null hypothesis. And that's the reason why I even use the test kit as an example. So it serves as a control line. And that is what you use to compare your p-value to accept or reject it.
Okay.
So you have to set it, your benchmark, the line at which you have to do that. So you have to set it. Okay.
All right.
Okay. So before I continue, I want to illustrate something. Okay. So now, I hope you guys remember number line. Do you remember number line? Gifty. Do you remember number line?
Sir, no, I don't remember.
Oh, okay. Give me some few minutes. Give me some few minutes. Who can remember number line? Who can remember number line?
Yeah, maybe Sopoku said yes, so maybe she knows.
So call her for me.
Maybe Sopoku, you can mute yourself and talk.
Maybe give
Just,
me
you
some
know,
few minutes.
to...
People are so busy talking somewhere, then they'll come and tell me that say I didn't get this, say I didn't get that. They've been Okay, so remember that um Josephine Osubempa, you have something to say? So if you remember number line, you say 0, write 0, write 1, you write 2, 3, so on and so forth. Do you remember those things?
Yes, sir.
Gift, you will kill me. And then you write -1, and then you write -2. I hope you remember that, Gifty.
Yes, sir.
So if you guys can remember, you can see that all the numbers on the right-hand side, they are greater than 0. True or false? True or false? Oh,
Sir, true.
good, good. So it means that every number that will come at the right-hand side of 0 is greater than 0. And then all the numbers on the left-hand side, are they greater or less than 0? Are they greater or less than 0?
Sir, less.
Good,
Less
good,
than.
good. Less than 0. Okay, so if you guys will permit me this time round, if you guys will permit me this time round, I'm changing 0 to be alpha. Is that okay? Is it okay with you guys?
Yes,
Now
sir.
I'm changing 0 to be alpha. And as I said, we are going to use this alpha to either accept or reject it, because that is what we are going to compare the probability values with. Okay? We are going to compare the probability values, and based on that, we are going to either accept or reject the null hypothesis. Okay? We are going to accept or reject the null hypothesis. And so let's assume, this is just assumption. Let's assume that the probability value associated with probably the first example that we did, the visit by the health workers, after doing everything, doing our statistics, computing this, that, and then we have a PV. When I say PV, the probability value of, let's say, 0.6. And we are using alpha to be 0.05. So compare the 0.6 with 0.05. Is it greater than the alpha or is less than the alpha? Again, now we are
Sir, it's
assuming that
greater.
It's greater.
it's greater. Good. It's greater. So let me write the 0.05 here for you guys. So if it is greater, now we are going to use the rule that whenever the p-value is greater than the alpha, it is in favor of what? The null hypothesis. That means that we are going to accept the null hypothesis. So whenever your p-value is greater than the alpha 0.05, we are accepting the null hypothesis. Okay. From the number line perspective, look at something. So if I want you to get this concept, and you don't need to memorize this rule. See, you can see that this 0.06, okay, it is going to be on the right-hand side of 0.05. Do you agree with me?
Yes, sir.
Do you all agree with me that it's going to be on the right-hand side of 0.05? Because it's greater. Okay, so if that is the case, then I can write here H subscript 0, H naught, which means that the null hypothesis. Is that clear? Again, let me go over again. Now, our p-value, 0.06. We are comparing it with the alpha 0.05. Okay, and this alpha 0.05, now we've seen that the 0.06 is greater than 0.05. So once it's greater than 0.05, and I'm asking, is it going to be on the right-hand side or the left-hand side of 0.05? And then you rightly say that once it's greater, it's going to be on the right-hand side. And I'm saying that since it's going to be on the right-hand side, we know that from the rule, anything that is greater than the alpha, it means that it is in favor of the null. That means we are accepting the null. And so we can say that everything on the right-hand side is for the null. And that's why I've written there now. Let me choose different color. Let me choose different color to write the null, so that I get the concept. So now I'm writing here H subscript 0 now, so that it means that any number that is greater than the alpha is on the null. So it means that we have the null on the right hand side. So it is in favor of the null. That means we are doing what? We are accepting the null. Good. On the other hand, let's assume that we are just assuming. We are not that we are just assuming that we've done some computations, everything, and then we found out that this time round, the test associated with the p-value associated with this is the 0.01. So I write it on the left hand side of your screen with red. So this time around we have 0.01 as, let's say, the new probability value. And this one, is it greater than the alpha 0.05 or less than 0.05?
So it's less than 0.0.
Good. And once it is less than 0.01, is it going to be on the left side of alpha or right side of alpha?
The left side.
Left side. Good. It's going to be on the left-hand side. And so the left-hand side, from the general rule, I can write H1 here. H1. So it means that, what it means is, any value that is less than alpha is going to fall on the left-hand side. It is going to fall this side. And so once it's falling here, then we can say that we are going for H1. That means that we are rejecting H0 and then we are going for H1. Don't forget that I stress on that it is always and always the null hypothesis that we test. And so we either accept or reject it. Okay. So whenever you go for the H1, it implies that you've rejected the null hypothesis. And whenever the value is greater than the alpha level, then it means that you are on the right hand side. And what do you have there? H0. So it means that this time around you are accepting H1. Another person too can say that, okay, this time around I'm going to make this side A. Let me draw another one here. So I'm drawing another one with color black. Okay, black on the left hand side of your screen. So I'm going to draw another one here. Another person too can choose to write it this way. The right hand side of alpha, so let me put alpha here. He or she can write A there. Do you get it? And then he or she can also write R here. Do you get it? Meaning that if a value falls at the left-hand side of alpha, it is R. What does R stand for? You are rejecting the null. Okay? So if you are rejecting the null, then it means that you are going for the alternative. And that is what is being stated here. And then the right-hand side is A. What do we have for A? A means that we are accepting the null. So it becomes very simple. Do you get it? So you would have to know the alpha level. If alpha is 0.01, whatever you compare, you have to compare it with that. If it is 0.05, whatever you compare, you have to compare it with that. Okay, so this, you can either go by this or you can go by that. So that you don't need to memorize it. Wherever you find yourself, be it exam, interview, whatever, you can just write this thing down. When you look at the p-value, you have to also look at the significance level. Compare. When you compare, it is greater. Oh, when it is greater, it's going to be on the right-hand side. Oh, what do we have there? A or H naught? Oh, A. It means that I'm accepting H naught. Whenever it is less than, it's going to be on the left-hand side. Oh, okay. Left-hand side, what do I have there? R. And R means what? I'm rejecting the H naught. And then you are good to go. Okay? How this will be very simple. I think I've made it very simple for you. Okay, so you don't need to memorize this thing. Okay, all these things you may think that it is weird. Okay, so let me just use this thing in relation to the first one, the one that we said that the visit by the health workers improve contraceptive usage. So now I'm now going to relate it to it. So the first statement or the first scenario where we are assuming that the p-value is 0.6. Okay, this is just assumption. So let's assume that after the test, everything, we are assuming that the p-value is now 0.6. Okay, so if it's 0.6, let's try and relate it to rejecting and accepting the first statement. Okay, so the first statement, the null hypothesis was the visit by the health workers did not improve contraceptive usage. Okay, and then the alternative was that the visit by the health workers improved contraceptive usage. So now you can say that since the p-value 0.06 is greater than the alpha 0.05, you are going to reject the null hypothesis. Again, you state that since the p-value 0.06 is greater than the alpha level 0.05, we are rejecting the null hypothesis. And now you can now go and conclude. Then you say that, and then you can now conclude that there is enough evidence that oh no, this one we are accepting. Sorry, we are accepting. Once it's greater is on the right hand side. So we are accepting. And since it is greater than that, we are accepting the null hypothesis. And now we can now conclude that the visit by the health workers did not improve contraceptive usage. And that's it. Now you are good to go. And normally I allocate more marks with the conclusion, because the conclusion is where you are going to apply your understanding or whatever. Okay. So again, I'm going again. Now we are assuming that the p-value is 0.06. This is just assumption. So we are going to relate it to the previous example. Okay. So now you can see that since the p-value 0.06 is greater than the alpha level 0.05, we are now going to do accept the null hypothesis. Since it's greater, because that's the rule, we are going to accept the null hypothesis. Okay. And now you conclude that the visit by the health worker did not cause any improvement in contraceptive usage. That is the first scenario. The other scenario that we are saying that we are assuming that the p-value is 0.01. So that one too, if it is 0.01, you can say that since the p-value 0.01 is less than the significance level 0.05, we are going to reject the null hypothesis and conclude that there is enough evidence that the visit by the health workers improved contraceptive usage. And then we are good to go. And these are some of the things that you do in exam or in your research. These are some of the things that you do. So that is it. Okay? And that's how you can relate it with that. And then these things, when we move to the next, our next lecture, that's next week, we'll be applying this in the computation of the the t-tests here and there. Okay, so you appreciate this one very well. Now it may look a bit abstract, where we get the p-values, everything is not abstract. It is there. I'll show you, but I want you to get the concept. So next week, we apply it. Okay. So that is how it works. And that is what you guys have been using there. Okay? That's what you guys have been using. Okay? So that's why now people are able to tell us that if you have these symptoms, it is likely to be this type of disease or whatever. It is based on this probability values. And that's why people are so much confident that if you take this drug, you are going to have this impact. It is based on these p-values. Okay, they will do the clinical trials. After the clinical trials, they're able to testify, oh, okay, this one is causing a significant defect, a significant change in whatever that they did. Okay. Okay, so that's just by the way, that is for you. I think with regards to this, I've exhausted the questions on that. But if you still have questions, I will take it from you. And then we move on to the next slide. Okay.
Index number, please unmute yourself and talk. Index number.
Hello, sir.
And
Please.
Yes.
Yeah, so please, do you have a recorded version of this lesson, like as you sent the last time, so that you can be listening? Because it's a bit confusing.
To be frank, this one I don't know, but but the school is recording this lecture, so definitely you get it. I requested from them too. Normally they edit the feedbacks that you guys give us, but for me myself, I don't have video on this. So I think those who will benefit from this will be next year, because I'll take this and put it in my Google Drive and start sharing with you guys. But currently, this one I don't have it.
Index number, okay? Please add the name to your index one.
Yeah. So please, henceforth, you have to add your name to your index number. Otherwise, we can't call you. Next week, you don't call index number. If someone has only index number, don't call that person. Only call names, please. Those who have their names and index number.
Okay, sir.
From next week going.
Sir, that's all.
Okay. Oh God. Okay, so I think I can clear everything. My dear, I think I can clear everything, right? Can I clear everything? Then we move on.
Yes, sir.
Yes, sir.
Okay. So now I think. So the p-value is what I've already explained. P-value, as I said, it is always associated with the test statistic that you compute. So I've talked about this, so I'm going to skip this slide. I think I can skip this slide. I've talked about the p-value, what it does, and how you compare it with the significance level for you to draw your conclusion. Okay. Okay, so I think I can skip this, right? So I think we should pay attention to this statement. You see that you can only know your p-value only after you've computed your test statistic. And that is the reason why I said that for exam's sake, I normally give the p-values. Okay, but the test statistic, students will compute it. Okay, so my sisters, don't worry. Things will be very simple for you guys. If only you practice, it should be simple. Okay. So I think I can move on. So now let me talk about the type 1 error and then the type 2 error. So the type 1 error, when we say type 1 error, what we mean is whenever you reject a true null. And that is the reason why I was stressing that this alpha is also termed as the type 1 error. So that is the reason why we always want the type 1 error to be something small, so that even if you make type 1 error, it's somehow negligible. Okay, and that's the reason why I was stressing that for health-related research, most cases, the researchers will settle on 0.05 or 0.01. Okay, so you will choose your significance level. So whenever you reject a true null, that means that the null is true, but you've rejected it. The null is true, but you've rejected it. Then it means that you have done what? Made type 1 error. You've made type 1 error. That's what we call by the type 1 error. And then the type 2 error is whenever you accept a false null. So it means that the null hypothesis is false, but based on your test, you've accepted it. Okay, based on your test, you've accepted it. And that is what we call the type 2 error. Whenever you accept a false null, that's what we call type 2 error. There's a sketch there, which I'm not going to talk about this, but what I want you to do is, God willing, next week we may visit this. I want you to analyze this thing. Look at the definition that I gave for the type 1 error and the type 2 error. I want you to look at that, and then you let me know if truly the sketch, or I mean the pictures that you have, they are type 1 error or type 2 error. Okay. Any question?
Sir, no question. Hey,
Oh.
Gloria, the
Sir,
co-host has
please, can you go over the type 1 and type 2 error again?
You just want me to go over. Just that you want me to go over. Okay, I'll go over. I said that for the type 1 error, whenever you reject a true null, when in fact it is true, you've rejected a true null, but in fact that null is true. You've made type 1 error. Okay, and then whenever you reject a false null, that means that, so whenever you accept a false null, that means that the null hypothesis is false. It's not true. But based on your test, you are telling us that it is true. Okay, you've made type 2 error.
Thank you, sir.
Do you have any other questions?
no, sir.
Okay. So please, I'm begging you, please, my sisters. I think what we have is the statistical decision, and the statistical decision is what I talked about, how you are going to accept or reject it. Uh, per before the introduction of the p-values, there was a way of doing the thing that we call the traditional method. And the traditional method, that one is a bit cumbersome. You need to calculate your test statistic. You go and read it from a table, and after that, you can do your comparison. And based on that, you are going to accept or reject it. But it's a bit confusing when you compare it with the p-value. So I'm not going to teach both. Normally, I teach only those who are doing the rigorous statistics. You are just applying it. And that's the reason why I'm stressing on the p-value. Okay. So we are going to use the p-value methods. Okay. But that's why I've already taken time to explain to you how you draw your conclusions. Okay. Based on the p-value. Okay. And then I've also mentioned that whenever you reject the null hypothesis, then that means that it is statistically significant. Okay, it is statistically significant. There's enough evidence to reject it. It is statistically significant. Okay, and this is what I summarized for you when I said that whenever the p-value is greater than the alpha, you are going for the null, and when it's less than, you are going for the alternative. And I'm stressing that whenever it is going for the alternative, that means that there's a change. Then you will see that there is some difference. There's a statistical significance. Okay, there's a statistical significance. So all these things I've mentioned it. So that's why I'm skipping. So God willing, next week we go through this process. We'll go through this process. Okay, where we are going to apply our dependent t-test. Okay, so we are just giving ourselves some few minutes for another questions. If we don't have questions, then I'll pass my comments. Then we'll end the class. Okay. So I'm waiting for questions for now. Oh, my dear, so we don't have any question? Okay. Okay, then let me just chip in this. Please, I'm pleading with you that God willing, next week, do your best to uh, revise on how to calculate mean and standard deviation. Okay, revise on how to calculate the mean and standard deviation before coming here. So next week we will apply it. Okay, next week we are going to apply it, the mean and standard deviation. Okay, so next week before you come, you try your hand on that. So Gifty, please send me hi. I'm going to send
Okay.
the lecture notes and then the videos for our subsequent meetings. I'm going to send everything to you. Okay, so that you get everything. You don't need to be requesting for it. Send me hi and I'll share with you right now. You can do it right now, and I'll also send it right now.
Sir,
So please,
done.
okay, so let me forward it to you. And while I'm forwarding the notes, please, if you have questions, you talk, okay? If there's no question, then I'm going to end the class, okay?
So I've sent the hi.
Yeah, I'm forwarding it to you. To check if you have it.
So I've seen it.
Okay. 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 So my dear sisters, if there's no question, can I leave? If you have any question. So if there's no question, then I'm leaving. Okay. Is that okay? Okay. Please, can I leave? Or you still have questions? Okay, so once nobody's talking, I believe that everybody's fine. Please take care of yourself and God be with us all. So God willing, we are meeting next week. Okay. Bye-bye.